Ever wondered why programming languages are so crucial in the digital era? Well, let's dive right in. Every app you use, every website you visit, every digital tool that simplifies your life, they're all powered by programming languages. These languages are the backbone of our digital existence. They're the architects of the virtual world, building and shaping the digital experiences we've come to rely on every day. Imagine programming languages as the world's languages, each with its unique syntax, grammar, and use cases. Just like you wouldn't use French to converse in China, you wouldn't use Python for a task that's best suited for Java. Each language has its strengths, its quirks, and its ideal applications. This diversity allows us to create everything from simple calculators to complex machine learning algorithms. So, understanding programming languages is like holding the key to the digital world. But how does one create a program using these languages? Let's take a journey through the process of creating a program. This journey features 5 stages: problem definition, algorithm development, coding, testing, and debugging. Each one of these stages is a crucial part of the process and contributes significantly to the final product. The journey begins with problem definition. The first step in creating a program is identifying and understanding the problem that the program is meant to solve. This is a critical stage because a clear understanding of the problem is what guides the rest of the process. It's like planning a trip. You can't decide on the best route until you know your destination. Next comes algorithm development. An algorithm is a step-by-step procedure for solving a problem. It's like a recipe for a dish. Just as you need to know the ingredients and steps to make a dish, in programming, you need to know the steps to solve the problem. Developing an algorithm involves breaking down the problem into smaller, manageable parts and arranging these parts in a logical sequence. Once the algorithm is ready, we move on to coding. This is where the magic happens. The algorithm is translated into a programming language, transforming our problem-solving steps into a language that the computer can understand. It's like translating a recipe written in a foreign language into your own language. After the program has been written, it's time for testing. The program is run to check if it works as intended. It's like tasting the dish you've cooked to see if it's good. If the program doesn't work as expected, it's back to the drawing board, or in this case, back to the code. Last but not least, we have debugging. This is the process of finding and fixing errors in the code. It's like finding out why your dish doesn't taste as expected and then adjusting the recipe. Debugging can be time-consuming and sometimes frustrating, but it's an essential step in the process. Each step, crucial in its own right, leads us closer to a functional program. Now let's take a brief detour into the world of coding. This stage is where the magic happens. It's where the algorithm, that abstract blueprint of our program, gets translated into a language our computers can understand. This is coding. It's the act of writing instructions in a programming language, which our machine then executes. But which language do we choose to speak to our computer? There are quite a few to pick from, each with its own strengths and ideal applications. Some, like Python, are prized for their simplicity and readability, making them great for beginners and complex projects alike. Others, like C++, offer more control over the computer's hardware, making them the go-to for performance-critical applications. Regardless of the language we choose, the goal remains the same: to bring our ideas to life, to solve problems, to create something new and exciting. Coding, then, is where our ideas take shape and come to life. So we've taken a whirlwind tour through the world of programming languages and program development. We've discovered the significance of these languages, just as diverse and complex as our human languages, each with its own syntax, grammar, and vocabulary. They are the building blocks that breathe life into our digital tools. From the most basic calculator app to the most advanced artificial intelligence systems. We've also examined the intricate process of creating a program. It's not just about writing lines of code, but about understanding a problem, designing a solution, implementing it, testing, and refining. It's a journey of continual learning and problem solving. Finally, we've peeked into the world of coding. It's the craft of turning our plans into a language that computers can understand. It's a skill that takes time and patience, but it's also incredibly rewarding. Remember, every digital tool you use is powered by lines of code written in a programming language. So, the next time you use your favorite app, spare a thought for the magic of programming.